So what we've seen is that a formal language is called a formal language, or a, sorry, is when you define a vocabulary with some symbol, right? Whatever this is, and we equal it to a subset of terms. And we can do some basic copying of those symbols to other symbols, and we can expand upon them. Let's say, for example, if we have this new vocabulary, let's say, so this was the squarish omega, we copied it to the end vocabulary, and now we have the so by doing this operation, right, the squarish omega equals the end with an asterisk. But here's what we can do also. We can add terms to them. So let's say A and B, for example, two terms that we added in the assignment of a new vocabulary. So what we get is the exact same from here, right? But now we will also get A and B, or with whichever notation you want, you can also write a subset AB depending on the context. But yeah, formal languages, they're very flexible, except when we start formalizing or formulating, for the lack of a better word. So in the beginning you can define all sorts of stuff, but then rules will have to start being applied, and this creates certain constrictions, limitations, and we have to follow certain patterns. And the end result is that we have a very organized structure of pieces of logic. Which we can use to construct more heavy-duty, more complex subsystems or complex systems of thinking, operations, any sort of computing. That's where they are born. So for convenience, we can accept as convention or axiom the use of propositional variables as, instead of writing A, B, C plus sigma or and bitwise or sigma, we will instead use P1, which is proposition 1 or premise 1, P2, P3, and so on. These symbols in logic of computation are sometimes, if they're few, they're sometimes referred to as P, Q, R, etc. And those we can put to use with some also conventional uh, logical symbols, which are called logical connections or connectors. Let's go to the next page. So logical connectors. What are these logical connectors? Well, they're symbols like this one, this one, this one, and this. Whoops, made a mistake here. And this one. And those are merely instruments in compounding terms, or let's say words, statements, and expressions, which are all very abstractly mentioned, but basically terms, as described previously, they're the most abstract form of symbol. Any symbol you can come up with. A word is a combination of these terms. Statements are going to be defined later, but essentially it's just determining Boolean expressions like A, B must be true whenever something else is true, right? Anyways, we'll talk about that later. For now, and expressions, we'll talk about them in a second as well. So these logical connectors are utilized to combine those. Actually, let me bring those up again, because even though I'm not going to talk about them now, it'll make sense later for them to be together here. These, they can be, all of them can be used with these logical connectors together into what is called a formula, or between formulas. Okay, let me actually, you know what? Let me actually include formula here. So logical connectors, okay, they interact with all of these, right? In between each other, and so on. And here's how they work. So every propositional variable, as we've seen before, can be stated as a formula. In fact, the reason I didn't include variables here, like variables, is that I didn't remember at the time to put them there, but it might as well have been ambiguous, because formulas and these, right, these propositional variables, they're the same. We can call a propositional variable a composition of, let's say, let's call P, right? It's a propositional variable. Let's call it P1. It's a composition of something else, A, B, and C. Or it could be that P1 is not in fact this. It could be defined as, well, it could be defined instead of terms, it could be defined as a word. A, B, D, I have to go to the bathroom, etc., something, right? So well, something is not very scientific, but what I mean is anything you can imagine, any symbol, any combination, anything of which I mentioned above can be compounded into a formula or variable, whichever you want to call it. And these variables are often represented with some unique conventional symbols, like the phi, or the whatchamacallit, or the, I don't recall the symbol, the name exactly, but you'll probably remember the, it's like a U anyways, or a V, both with traces. And so what we have until now is that we can have variables, right? We can have certain groups, logical connectors, and this is the syntax we'll use, right? The logical connectors being, of course, this one, this one, this one, and this one. Actually, let me fix the one on the right. Yeah. And these formulas, connectors, they can be seen in many usage cases, scenarios, like this, for example. The symbol right here, and an O, or let's say that same symbol, the phi, using that symbol with the U. That's another word for them, just reiterating. Nicer. So yeah, we'll see some of these happening quite often, and we'll begin by defining what is the meaning of these operators, these connectors, and how the variables or formulas can behave with them.